All right, let's go ahead and get started with 2.5 measures of the center of the data. So when we're discussing the measures of the center here, we're going to have these things called central tendencies. These things are roughly called going to be the average, the median, and the mode. We have three of them that we're going to be talking about. But we need to establish what we are analyzing, the central tendencies of a population or the central tendencies of samples. Those are going to be different, and they will be different as we go on. The center of the data is also a set that is a way of describing its location. The two most widely used measures of the center of the data are called the mean, the average, and the median here. So we have both of those that are usually what we call the center around the data itself. So a parameter is a descriptive measure of a population. A statistic is a descriptive measure of the sample. That's something that we are just talking about. And then we talked about in chapter 1, which is actually right now what we're talking about. Parameters are often written using the Greek letter mu, which we call like this, mu, and statistics are often expressed using the Roman letter x bar, is how we usually talk about these. So let's talk about the arithmetic mean and for the population and the sample arithmetic mean. So for the arithmetic mean, it is also known as the average. They're both usually the average here for the arithmetic, for the population mean, and the sample arithmetic mean. And all you do is you take the sum of all the values of the data set and then you divide them by the total of the observations themselves. So it is computed by the all observations, and we usually use this mu here like this, which is right here. And then we use this thing x bar for the statistic. So remember, mu is a parameter, x bar is our statistic here. And another key note is the capital N represents the size of the population, whereas the lowercase n represents the size of the sample. So you just got to make sure that when you take the average, you got to make sure you're dividing by the correct number here. So once again, this one here, we write like this, kind of like a U with a long curly at the left and the front, is for population, mean, and x bar is called our sample mean. All right, and let's go ahead and let's try out some examples here. So the following data represents the travel times in minutes to work for all 7 employees of a startup web development company. We have 23, 36, 23, 18, 5, 26, 43. Compute the population mean here. So first thing I want you to notice is that we are talking about for all 7 employees. So that immediately tells me this is a population and not a sample. So we're already dealing with a parameter, not a statistic. Okay, that's the first thing. The second thing is, it also says it right here, which is pretty obvious, population of the mean of this data. So that's another way we can obviously tell it. And the last part is it says round to the nearest hundredth. So we got to make sure we round at the very end here. So let's talk about how do we actually find the population mean. So remember, this is mu, and it says that mu is equal to the summation, is if you remember this from Math 3A, of xi, all divided by capital N. Now, what does that summation mean? This summation right here just means you add up all the numbers starting with the first one all the way to the last one. So if we look here, let's look at all the terms we have here. We have 1, 2, 3, 4, 5, 6, and 7 here. I think I'm actually going to take off all the circles. So we'll just go with 1, 2, 3, 4, 5, 6, 7, because it's easier for me to see. All right, so what we're going to do is we got to add up all of them, and then we got to divide by the total number that we have. So in this case, I'm going to add up 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43, and we're going to divide all of that by the total number here, which is the number 7. Now, the first thing I would do is I would not put all this in the calculator right away, or you can if you want to put parentheses. I just like to do the top first. So I ended up getting 174 divided by 7, and I now get 24.8571. And there's a little bit more, but I just kind of stopped there. Now, remember, we're trying to round to the nearest hundredth, so we need to stop after 2 decimal places. But we got to make sure we look at the last one right here, the one right after the last decimal place. Is it bigger than 5? If it's less than 5, since it's bigger than 5, we go up 1. So I'm going to move this 5 up, so it becomes now 24.86. So my mu here is going to be 24.86. Now, this is the correct answer, but this is not the full answer here. When we get this and we talk about means and all this other stuff, we want to answer appropriately in terms of what the study was actually talking about. So we're going to write over here the mean time for traveling to work and make sure it's legible and practice working on your legibility for employees at this company is 24.86 minutos. Okay, and that is how we compute our population mean, and more specifically, we compute our parameter here. And that's kind of it for this one. All right, let's go ahead and keep going. So we're still going to use the same example that we just used here, and what we're actually going to do is we're now going to talk about how do we find some sample means. So in this example, you're going to use your calculator to take the simple random sample of n equals 3 employees. Well, you're probably thinking, how do I find a simple random sample? We're going to compute the sample mean of it, obtain a second one, and then again compute the sample mean one more time. So we're going to do this, and we're going to do this with, we're going to go ahead and we're going to open up NumWorks, and I'm going to go home and I'm going to go to calculation here. So before I do that, I actually have to do one more thing. We're going to need to reorder the data here, and we need to put the data on this side of the paper so that way we don't have to keep flipping back and forth. So I'm going to write right here 23, 36, 23, 18, 5, 26, and 43. And I'm just going to number them off again. 1, 2, 3, 4, 5, 6, 7. Now what I need is I need 3 random numbers here from 1 through 7, and that's going to give me my random numbers here. Now we could obviously just pick 3 random ones here, and that would kind of do the work, but we want random, like completely random. I want something else telling me what numbers to use here. So I'm going to go into calculator, and I'm going to go ahead and go to our toolbox again. We're going to go to probability, we're going to go to random, and I want random integers with no repetitions. I'm going to go from the number 1 to the number 7, and I want 3 random numbers here. I don't know what they are, but I'm going to get them. 7, 1, and 5. So my first one is going to be the numbers 7, 1, and 5 here. Now remember, I'm going to go ahead and use the X bar because I'm trying to find my sample means. So remember, we're doing sample means. So that means I'm using X bar. So my X bar is going to be equal to, sorry, I forgot what numbers were they? 7, 1, and 5. So we're going to use the numbers, the positions, or AKA our locators, as 7, 1, and 5 for the first one. So the 7th position here, so because it's 7, we're going to use the number 7, which is 43. So 43 plus the number 1. So the number 1 here is 23. And the 5th one, which is the number 5. So plus 5. And we're going to divide all of this by the number of terms that we're actually using for the sample. So the number of items in our sample here. So since we have 3 of them, we're going to divide by the number 3. And if we go ahead and compute this, so 43 plus 23 plus 5, that is going to give us, all divided by 3, 23.67 here. And so that is our X bar here for this first one. Let's go ahead and do this again, and we're going to do it for a different set. I'm going to use, let's just go ahead and we can go ahead and copy this and paste it again. We get 6, 7, and 3. So let's use 6, 7, and 3. 6, 7, and 3 now. So my X bar is now going to be equal to the 6th term, which is 26, plus the 7th term, which is 43, plus the 3rd term, which is 23. And I think this one I don't have written down, so we're gonna go ahead and do this one. So 26, 23, 43. 26 plus 23 plus 43. I believe that's correct. All right, and we're gonna go ahead and hit okay, and then I'm gonna divide this. All right, okay, divide by 3. That gives me 30.666. So I'm gonna write right here, X bar is 30.66. And then since it says another 6, we're just gonna round it off to 30.67 is my X bar. All right, and then the last one we'll do one that I already kind of did, and that's gonna be the X bar, and that one gave us the 23. So I believe the numbers was 1, 18, which is 4, and then 43, which is 7. And so X bar is going to give me 23 plus 18 plus 43, all divided by 3. So my X bar ends up being exactly 28 here. So you'll notice that you see all these are all actually different. They're all different compared to the one we found at the very beginning on the previous problem. Now, why is this? Well, this is because our sample is a lot smaller now. We're only using 3 of the numbers here, but because I'm choosing different numbers every single time, my mean is changing every single time. So it kind of makes you think of, well, if you select data a certain way, you can prove that the mean is bigger. Or if you choose them a different way, you can prove that it is actually smaller. So sometimes being selective with your data is sometimes bad and sometimes it's good. We just gotta kind of figure out when to use which. All right, let's go into determining the median here. So how do we find the median of our data in the other example here? So example 2.15. So remember what the median is. The median is the middle, or AKA the 50th percentile. So the first thing we have to do is we actually need to order the data that we were given. So I've already ordered it, so I'll write it down for us. So we get 5, 18, 23, 23, 26, 36, and 43. The next thing we're gonna do is we're gonna go ahead and number them off. So I'm gonna number it right here. 1, 2, 3, 4, 5, 6, and 7. Now, if you remember back when we were finding the median and this thing called the locator for our quartiles, we're gonna do the same thing here. Our locator is going to be 0.5 times n. Why the 0.5? Because that is 50%. Because remember, this is the 50th percentile. If we were finding the first quarter, we would use 0.25, and if it was a third one, we use 0.75. So remember, what is my total number here? My number is 7. That's my capital N here for this kind of population, or for this set. So this one's going to be 0.5 times 7, which is obviously not going to be a whole number. It's 3.5. Now, because it is a decimal, we are actually going to round. So now we're going to go ahead and round upwards to the nearest integer 1 up. So my L is now going to be 4. Now you're probably wondering, why are we doing this? Didn't we just add these two numbers? That was because we got whole numbers last time. Now that we have a decimal, we actually have to round upwards, and I'm going to show you why in just a second. So now we're going to pick the 4th locator. So we're going to go ahead 1, 2, 3, 4, and that is going to be our median here. So this is our median. Now you're probably wondering, why did we just pick that randomly? That kind of felt like it was just random. Well, remember that the median is supposed to be exactly 50th percentile, half of the data. So let's look at the previous ones. We have 3 right here, and we have exactly 3 right here. So there's 3 above and there's 3 below, aka 50% above, 50% below here. And that is how we find our median. So there's 3 right here, and there are 3 of them right here. And that's how we find our middle ground in between all of these data here. So let's go ahead and interpret what this all means now. If we find the median, how does this kind of work with our entire thing, and what does it talk about with our minutes and everything else? So remember that the median is once again half, but it's half of the workers have a travel time of less than or equal to 23 minutes or minutes. Okay. Now, that's also one way of saying it. Another way of saying it is also saying that half of the workers have a travel time greater than or longer, because we were talking about time. So greater than or more, but we're going to say longer because it's time. Longer than 23 minutes or minutes. And so that is our interpretation of what this mean means in terms of our data itself. Let's go ahead and keep going. So suppose in the example 2.5, the startup company hires a new employee. So we get a new person. The travel time of the new employee is now 70 minutes. It's a whole hour and 10 minutes. Man, that's crazy. Determine the median of this new data set. So now what happened is we just added a whole nother number here. So we're still going to do exactly what we just did before. And the very first thing we need to do is we need to order if we're finding the median. So we got to go ahead and we got to order. So I'll reorder it. So it's going to be 5, 18, 23, 23, 26, 26, 43, and 70. And now once again, I'm going to order it. So I ordered it from least to greatest, and now I'm going to go ahead and number it. And let's go with this one is 1, this one is 2, 3, 4, 5, 6, 7, and 8. So we now have 8 of them. So my new capital N is going to be 8. Now my locator, once again, is 0.5 times the amount of data I have, which in this case is 8. So my L is actually 4. So remember that when we find it and we have a nice whole number here, we have to also find the one above it, which in this case, L plus 1 is just 5. So we're going to take the 4th and 5th number here. So that's going to be 23 and 26. And we're going to go ahead and find out what this median is. We have to take the average of those ones. So my median for this one is 23 plus 26 divided by 2, which is 49 divided by 2, which is 24.5. So once again, we want to interpret this. Now, what does this median mean? This means that the median travel time for the employees is 24.5 minutes. Now, so this is the new time. So the median travel time is now 24.5 minutes. Something I want you guys to note here is that the median, when comparing it to the one before, it didn't really change very much. So the median did not change much even when introducing a large outlier, large or extreme value. Okay, so the median doesn't really change much when we are introducing it to a big value or even a different value in general. All right, let's go ahead and keep going and we can talk more about this. So the explanation for a statistic to be what's called resistant here. So let's go ahead and look at our following data one more time. And let's just say now, what if I hired someone that has now 130 instead of a 70 minutes? So let's say the 70 minute guy, he came and was gone. He was like, I can't do this anymore. But then somebody new came and they're like, I can do a long commute, even longer than he can. And that's a 130 minute commute now. So now we're just gonna basically add in over here 130. And now we have to find the median, and we're also gonna do the mean as well and find both of them. Now, in case you kind of don't realize it, if I even add 130, it's like changing this 70 right here to the number 130. I didn't even use the number 70 at all in my calculation of the median. It actually doesn't change, doesn't matter what this number is, as long as it's more than 43, it doesn't really change anything at all. So what this means is that even when we have these 8 employees, so I'm gonna put over here, 8 employees, and we find the median, it's still gonna stay exactly the same as when we had the 70-minute person. It's still going to be 24.5. Why is that? Because the 130 is still just as big as the 70, if not larger, but the 70 didn't do anything to my actual median itself. So it's just gonna stay exactly the same here. So with that, we're gonna go ahead and find now the mean. And let's go ahead and find the mean here. So the mean is going to be where we add up all the numbers here. So we gotta add 5 plus 18 plus 23 plus 23 plus 26 plus 36 plus 43 plus 130. Add all of those numbers up, and then we're going to divide by however many numbers we have. In this case, we have the number 8. And that is going to be, when we put in the calculator, 304 divided by 8, which is equal to 38. So that is now the mean for this one. So if we look at here, this is now the new mean, and this is the new median. What was it when we had just 7 people? When it was 7 employees, without this new person, so before this new guy came in, the median was 23. The mean, however, was 24.86. So in case you can't see here, we have 23 for this median, and we have 24.5 for this one. That's a whole only 1.5 difference. It's not very big. But this one goes from 25 all the way to 30. That's 13-minute difference here in that sort of mean to mean. And that's a very huge difference. So when this happens, we usually say that the median is resistant. And in this case, the mean is not resistant. It means that it gets pushed left and right because it's not resisting what's happening here. So the numerical summary of a data said to be resistant if extreme values, very large or small, relative to the data, do not affect the value substantially. And in this case, the median is resistant in this example. All right, now let's go ahead and keep going. The next one says the third central tendency is called the mode. So the mode is the most amazing thing because it can be computed with quantitative and qualitative data. So basically we can do it with categorical data or numerical, so for numbers or categories themselves. The mode of a variable is the most frequent observation of the variable that occurs in the data set. We also have things called no mode, one mode, or there can also be more than one as well. What happens when there's a no mode, that means that all the observations occur, so no observations occur more than once, or they all only occur one time itself. So this one we probably have seen before, hopefully. What is the mode for the weights? All right, so what is the mode for the weights here? So the mode in weights of the 10 students in the nutrition class. So we can see here that we want to find the one that happens the most frequently or has the most observations. Obviously, we can see that 117 is right here and 117 is right here again. We have 2 of them. So therefore, the mode is 117 pounds. And in this case, this just means that 117 occurs the most. All right, let's go ahead and see what happens if we deal with categorical data. How does that look? Well, we want to see all these words here, and it gets a little confusing, I'll be honest. So let's start off with just writing them over here. We have blue, we have red, and we also have green. And let's just count all of them. So we have 1 blue, 2, 3, 4, 5. So we have 5 blue. Let's see, how many red do we have? We have 1 red, 2 red, 3 red, 4 red, 5 red. And how many green do we have? We have 1 green, 2 green, 3 green, 4 green. We have 4 green. So in this case, there are actually 2 modes. So we say right here, and we have to acknowledge both of them. There are two modes, red and blue. Because they occur the same amount, there are two modes, and it's going to be both of them for this one. All right, let's go ahead and keep going to the back side now. So let's calculate the mean of a frequency table. So what happens, whoops, sorry. Let's say we go to a frequency table here. If we want to calculate the mean of this one, how do we calculate this? Well, let's talk about what frequency actually means. It means how many observations we have of that specific number. In this case, if we say 85 and the frequency of 4, we're not just going to write 85 once. We actually have to write it 4 times. So let's go ahead and write this out. It would be 85, 85, 85, and 85. That's what frequency means. It means that there are however many of that, that's how many we would write down. So if it's 4, we would write 4. If it's 2, we would write 2, and so forth. So let's go ahead and let's write them all out. We get 98, 98. The next one is just 100. We get 110, 110, 110, and 110. The next one is 115, 115, 115, and then the last one is, I'm running out of room, 138 and 138. Okay, so now we've written all of them, and then we got to add them all up in our calculator to help us out here. So something that can help you out with doing this part, in case you can't really see maybe with repetitive addition, is when we write our, for this one, we want to find our X bar or our sample mean. Okay, so this is still our sample mean here, or our X bar, is we can write it like with multiplication. Because we have 4 85s, we can just write 85 times 4 plus 98 times 2 plus just one regular 100 plus 110 times 4 plus 115 times 3, and then next we have is plus 138 times 2. And that's going to be all divided by however many numbers we have. So we can go ahead and add them all up. Now you can count them here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. You could do it that way. You also could have just added up all the frequencies. And if you add all these numbers up, congratulations, you still get the same answer. It's going to be 16. So we can divide all of this. Remember, this is going to be adding up all of them and then dividing them by however many we have, which is 16 here. So my X bar is going to be, I like to just add up the top first, or multiply out the top, or simplify it. 1,697, all divided by 16. And that's going to be now 106.0625. We obviously need to round, so my X bar is going to be 106.06. Once again, we draw the line off, and then we look at the one before it. We go down or stay the same, basically. So we keep it at 0.06. And that's how we find the mean on this one. All right, let's go ahead and let's talk about calculating the mean of a group frequency table using our calculator this time. So you'll notice here that we have this thing called groups. Okay, if you remember this example back in chapter 1, we have these groups here that go from 140 to 179, 180 to 219, 220, and we just keep going here. Sometimes we use the lower limits. In this case, we actually want to use the midpoints because the midpoints are exactly half. Like we said before about the frequency, we get 4 of them. But if I were to find out what the values are in here, you might get like a number like 150, you might get 157, 160, and they're still in this group, but we can't tell the difference. So we just use midpoints because they're more solid, and it makes more sense for us to just use at least the average number of all of them. So we're going to go ahead and we're going to use the midpoints here instead to estimate the mean. Okay, and we're going to go ahead and put this into our calculator on the numworks. So I'll go here, the numworks. We're going to go to statistics, and we're going to go all the way over here to data. And I'm going to go ahead and delete all of these. and we're gonna go ahead and put them in. So I get the first one is 160, and then I get 200, 240, 280, 320, 360, 400, and 440. Okay, and now I'm gonna go all the way up and I'm gonna fill in the frequencies, and I'm gonna get 4, 1, 4, 6, 10, 6, 2, and 3. All right, and now what I'm gonna do is I'm gonna go ahead and go to stats, and stats is gonna have all of our stuff again. So it has everything, and it even has our mean here. So if we go down, we find our minimum, quartile, all this stuff, and then we get our mean. Now you'll notice that it says the population mean because the calculator itself does not know if it's a sample or population. It just gives us the population because that's how it will be taking it as. So in this case, we get 304.444. So we know that it's a sample, so we're gonna keep it as a sample. And we're gonna go ahead and write right here 304.44. Once again, we have another 4, so we cut it off right there because we want 2 decimals. It's still here, so it's just gonna be X bar is 304.44. The next thing we wanna find is the median, which it also has here, so we'll write it down. And if we look here, the median is right here, which is 320. So the median is 320. All right, and before we end this part, let's just go ahead and write this part down because I forgot to write it. So in order to find this on the NumWorks, we go to statistics. So go to statistics. And then number 2, you're gonna fill in the table. And then lastly, you're just gonna go to stats. And that'll give you all of your information for mean and medians. All right, and that's all for this one.